11.6, making decisions and predictions. I can use probability to make decisions.
Nice job, Romeo. Woo! Proud of you. All right, you guys. I told you long ago that chapter 4, when we did rates and proportions, would be the most important part of the 6th grade year. Rates and proportions now have come back in our probability unit. This is the last lesson we're going to do in probability, and we use rates and proportions to help us with probability. You understand what I'm saying? They're very, very helpful and beneficial. So our first problem, really quickly, 500 customers are surveyed in the Eden Prairie Target, and this is what they reported. 35 people said they were unhappy, 340 people said, it was just fine, and 125 people were like elated. They were ecstatic. They were pleased. They loved their experience. So whoever collected this data had to go back and figure out how many people are unhappy with Target through the course of the day, and they know that about 500,000 people go to Target across the country, across the world each day. So they wanted to figure out how many people are unhappy when they go to Target. Well, if in Eden Prairie, 35 are unhappy out of 500, we could set up a proportion and figure out how many are unhappy over 500,000, couldn't we?
Yeah.
Yes.
So we already have everything we need. The only thing we need to find is x. And can we find x?
Yes.
Using what method?
Bubble.
Bubble. How do you get from 500 to 500,000?
Times by 1,000.
So if you multiply the bottom by 1,000, you multiply the top by
1,000.
And what is 35 times 1,000?
35,000.
There are 35,000 unhappy customers at Target each and every day. Is that a bad thing?
Yes.
Target wouldn't be happy by that. Okay, next one. Same concept. Svetlana loves to play cards. She didn't have anybody to play with, so she made up her own game. She decided she was going to guess what card she was going to draw from a deck of cards, and she did this 1,000 times. We want to know how many times would she be right. The first thing we need to do is calculate the theoretical probability, right? A deck of cards has how many cards in it?
52.
If you draw 52 times, how many times would you expect to get it right?
1.
1 out of every 52 times, right? Because you're going to have to pick a card, and one of those 52 cards is going to be right. So that would be the first part of our proportion. If we drew 1,000 times, we're just missing this, x, right? So how do you get from 52 to 1,000? They're not friendly numbers, are they?
No.
So what we said is well, let's use our calculator. Let's pull out our calculator and let's do 1,000 divided by 52. We get 19.2. I mean a big number, but I rounded it. And we know that to go from 52 to 1,000, it's got to be a number greater than 1, right? So whatever the bottom number is, we multiply the top number, and we came up with approximately 19 times. Now Ben and Nick in the back of the room there, they used a what?
Ratio table.
Ratio table. I'll do a really crude one. They said, well, if 1 out of every 52 works, what'd you guys go to next again?
500.
How many out of 500? So they multiplied the same thing. They multiplied by 19.2, right?
Mm-hmm.
No, by 9.1, right? How do you get from 52 to 500? Is it 9.6?
Yeah.
9.6. And then they made this 1,000. They multiplied by 2. They multiplied by 2, and they got 19.2 times, which is approximately 19. So ratio tables work as well. And then down here, the last one, Mo and Sean are flipping the coin. Mo wins if exactly one coin land heads. If not, Sean wins. Prove whether or not this is a fair game. What do you got to do?
Tree diagram.
The tree diagram. If Mo flips first and gets a head, Sean's going to get a head or a tail. So there's 2 of our outcomes. Head, tail. If Mo flips first and gets a tail, Sean's going to get a head or a tail. Here's our another 2 outcomes. The direction says exactly one coin, right, Isaiah? So if exactly one coin lands heads, is this a fair game?
Yes.
Yes or no?
Yes.
And then down here, because Mo hates losing so much, he changed the rules. We redid the rules. We made another tree diagram, and we determined it wasn't a fair game, and you can read that one on your own.